A 3D printed adjustment tool for the power amplifier inductors on the Cybernet 134CB radio chassis. Hi guys, welcome back to the channel. We're looking at the inside of a York JCB861 based on the Cybernet 134 chassis. Sure, those of you who know your old CBs will have already recognised that this is a Cybernet 134. So, these three cores here in the back, as you'll probably know if you're a regular viewer to Richard's UK FMCB radio servicing channel, you've got to know that you've got to balance these out properly. So the radio's doing 4 watts, and that's across all channels from 1 to 40. And you can't just leave these set at maximum at 5 watts or whatever it is, otherwise smoke will probably start coming out, and that's not usually a good thing. So you need a tool that will fit those cores. Now, one of these cores is broken. Yeah, I'm not sure if you can see that, but I have featured this on the channel before. This is the same radio from then. There, I'm not sure if you can see that core's broken, but it is broken. I know it's broken. The other two are actually intact. The golden screwdriver's unfortunately been in here, so it's not ideal. So I discovered that when I was initially tuning this up, that core was broken because it, well, yeah, and I didn't have this either. This is a 3D printed tool that I've done in the last couple of days that will fit those cores and will adjust them. So I can actually demonstrate that right now. Yeah, okay, so I've got the power meter in front of me here. This radio's doing close to 5 watts apparently. So if I start adjusting these coils in here, that should come down. And it has. That is using the 3D printed tool that I showed you at the beginning. Nothing fancy here. Turn it, goes up, turn it, goes back down. Don't want to be doing that for too long. The PA will overheat, and that's not ideal. Now onto a different one. There's only 2 of these I can turn. One of them's broken. So this radio's a little out of tune at the moment, because obviously I can't do that 3rd core. The other cores I can do perfectly fine. None of them seem to have suffered the fate of the golden screwdriver, unlike that green one, which is very, very annoying indeed. But otherwise the radio seems fine. There is a bit of tarnishing on one of the presets, but that looks relatively fine. And deviation hasn't been set on this either, because the deviation controls aren't set how they would normally be set. I can tell just by looking at them. But this video is more about the tool that I 3D printed, and the fact I can turn the cores with it to make the appropriate adjustments. So as long as I don't try turning the cores too far, then that should be fine. Because if I turn them too far, they will break. Let's key that up again. That's a little lower than what it was. That's probably a bit better. So it's out of tune, but that's fine, because I'm going to tune this radio up properly once I can get that last core fixed. Now, if I can get hold of a scrap Cybernet 134 chassis with those cores on it, then I might be able to sort that out. However, it looks like I can't at the moment, because I don't know where I can obtain those cores from. If you can even obtain them at all. That's the thing. Just try to stay close to the mic here. So The tool fits, it turns the cores, and I can actually demonstrate that as well. Okay, so the tool is in the core here. I turn that, not sure if you can see this. Not sure if you can see that at all. So let's take the core tool out. So that looks a bit lower than what it was. Try turning it the other way. That looks higher. So it definitely turns that one. Let's have a look at the brown one, which is that one. Might need to put my fill light on for this actually, I don't know. We'll see. So there's the brown one. Turn that. That's lower. That appears to be higher. And that's at the maximum. So, my advice, always use the correct tool. Don't be like the screwdriver experts and so-called rig doctors, or you'll end up with something not too dissimilar to what's happened to the green one. I really don't know if you can actually see that. See if I can zoom in a bit on that. Yeah, as you can see, that one's broken. I do have a short on that somewhere on the channel. Somewhere. Let's try and get the zoom the right way. So, yeah. That's a 3D printed trim tool for use in those cores. Make sure you're using the right tool for the right job. And don't just use a screwdriver on any of these cores or an Allen key in the case of those, because you will break the cores. So, next we'll have a look at the computer and have a look at how it was all designed. Right, I was going to do a screen capture here, but unfortunately that hasn't worked out, so I'm having to film the screen with the camera instead. So, I've got DesignSpark mechanical on the screen, and so it's quite a simple job to do this one. So all you need is to draw some hexagons using the polygon tool, and then circles using the circle tool, and then pull those out and delete anything that's not necessary. So it's quite simple to do. I had to extend this by an extra, I think it was about 10 mil I extended that by, because it was originally slightly shorter and was bottoming out on the plastic formers for the inductor coils, whatever. I think they're formers, I'm not sure. But the thing that the core actually sits in. Because I think it's a former, because I think the coil is actually on the outside and the inductance is changed by that ferrite slug that's inside. So that was extended because it was bottoming out, and then was 3D printed a second time. I do have the first original one in the shack after I tried it last night. So that's what we've got here. Then I had to send that to Ultimaker Cura. Now, the version of Ultimaker Cura I use doesn't directly take files in from DesignSpark Mechanical. So I can't just click that and then that. I have to just go to create the STL output down here and then send it to Cura, and then that will, of course, allow me to slice the piece up, ready for creating the G-code and 3D printing it. So, not an expert at 3D printing, so I might get some of it wrong, but I have a rough idea of how to do it. So let's have a look at Ultimaker Cura. So here we are with Cura. So what I had to do to 3D print this was select the object. It always gives me this warning. I don't know why, because I can't see anything that would be particularly wrong with it to cause that. So then I have to select the top view, and that's the view of, that should be the view of the item from the top. Then I'd want to select the rotate tool and then select the face to align to the build plate. If if I can select that. And hopefully, if we look at that from the front again, now that hasn't actually done what I wanted it to do, so go back to the top view, select that again, select that, and then hopefully if I go back to the other view, there we go. So that's how I printed it, like that. So I had to put supports and things in as well. I'm not going to slice this again because it doesn't need to be done. And I could just print it straight off the SD card. I'm not going to print another one for this video. However, I do have it uploaded onto Thingiverse. The link for that is in the description below, and there's also a short on this item. So if you're stuck in a bit of a pickle for a trim tool to fit those cores, have a look on Thingiverse for it, or just click the link below this video, and with a bit of luck you'll end up with something that will hopefully fit those cores. And you can tune up your Cybernet 134 radio. That's your Rotel, your York, your Harvard, your Harrier, or even there's a Midland base station that has the Cybernet 134 chassis in it. It may also fit the 54 meg trap filter adjustments in the Binatone Route 66, but I can't confirm that because I don't have one of those radios to test that. And to be honest, I wouldn't want to mess with that anyway because I'd need a spectrum analyzer connected directly to the thing, and at the moment I don't have any means to directly connect my tiny SA, so I'd rather not blow that up. And I don't have a Binatone Route 66, obviously, as I said. So, bit of 3D printing that helps in the world of repairing CB radios. And hopefully that will get me able to tune up the transmitter in plenty of Cybernet 134 radios. And if I need another one, I'll just go to my 3D printer and print another one. So Paul, Mike 0, Whiskey November uniform, or 26 Charlie Tango 730 if you catch me on 11 metres and PMR 446, or just the red squirrel on the old CB and PMR 446. If you like, if I can get that York going, it needs a new speaker as well, and that would be absolutely brilliant. And I just need a new speaker and a new one of those cores. It looks like I might have to completely desolder that inductor as well to actually replace it, but we'll see. So the source of those cores would be good, but I'm not sure where you get them from. And I didn't want to pay the charges for bringing in a set of tools from America, because that would have cost far too much, and I'm not paying the shipping costs plus the cost of the item. The shipping's going to be worth more than the item anyway, so I've got a 3D printer, put it to some use. So 7.3 for now, and I'll catch you in the next one.